All right, so we're solving another one of these tough problems that has a variable divided by the fraction. So the first thing we did was our KCF process of keep, change, flip, because we don't like division by the fraction. So instead of dividing by the fraction, we change division to multiplication. We flip the fraction to get its reciprocal. The right side stays the same. And then I used, and I didn't say this the first time, but this is the commutative property, allows us to change order because commute means to move. So the commutative property let me switch the order of the multiplication. And now we were saying normally when we see multiplication, what we think is, oh, we should divide. But actually here, what we want, and this is like what we're thinking in our head, what we want is 1t, right? Like 1 times the t. So we're wondering, how do we turn 12/5 into 1? Well, a fraction times its reciprocal, or like it flipped over, right, equals 1. So all we need to do is multiply with the reciprocal. So the reciprocal of 12/5 is 5 over 12. And we're going to do that on both sides. Now my left side, I'm going to write my in-between in like a lighter color just because I think that kind of helps. 5 times 12 is 60. 12 times 5 is 60. What is 60 over 60? 1, because any number over itself is 1. So this becomes 1, which is what we wanted, right? We wanted 1t. And since we were multiplied by t, we're still multiplied by t, still multiplied by t. My right side, I got to do the math, so to multiply fractions straight across the top and straight across the bottom. So negative 3 times 5, negative 15, 10 times 12, 120. I'm going to rewrite this down here before I start trying to reduce it. So negative 15 over 120. We see we end in 5 and 0. What does that mean we could divide by? What can we divide 15 by? Let's ask that question first. So when we end in 5 and 0, that's my job, right? You're totally allowed to say, I don't remember, because that's my job. So when we end in a 5 or a 0, we know we're divisible by 5. So to reduce this fraction, I'm going to divide the top and bottom by 5. And this isn't always necessary. It's always good to reduce fractions. Excuse me, but sometimes they'll just say, give the answer as a fraction. If they say, give it in simplest form, it needs to be reduced. So 120 divided by 5. 100 divided by 5 would be 20. 20 divided by 5 would be 4. So I think we get 24. I just kind of broke up the number into 120 and I divided them separately by 5. That got me 20 plus 4. That was kind of the little process I did in my head there for that division. So I get negative 3 over 24. Now I again look at both of these numbers and say, can they be reduced? Yes, because they can both be divided by 3. So remember, whatever we do on top, we got to do on bottom. So we get negative 1 over 8. So this, negative 15 over 120, is actually just a complicated way to say negative 1/8.
That's a lot.
Yeah, so we probably, I don't know if it is going to ask you to reduce it on the problem that it gave you. But so again, just to review what we did, and I'm going to send you this video like after it uploads. We started with a variable divided by a fraction. We don't like division. So division is bad, or at least division by a fraction. So we make it multiplication by doing keep, change, flip, right? So that's how we make things into multiplication. So we did the keep, change, flip process. The 5/12 flipped over to become 12/5. It became multiply. Right side stayed the same. Then to turn my fraction times t into 1 times t. We multiplied the fraction, written here in black, by its reciprocal, written here in green, if you can tell the difference between those colors. And because we did it on the left side, we also did it on the right side. We did the math, like multiply across the top, multiply across the bottom. And then we simplified our fraction by dividing by the same thing on top and bottom. So this was just simplification, and this was just simplification. So this is the same answer, quote unquote, the same answer, we just use different numbers.